Hey everyone, in this video we are going to look at some problems where we're given the probability that an event takes place and then we work backwards to find the value along the normal curve. So I'm doing this on my iPad so that I can do some drawing as we go because the pictures really help here. But Excel, the functionality should be the same regardless. So let's start with this warm-up problem here. We have some pretzels, and the time required to bake a pretzel is normally distributed with a mean of 15 and a standard deviation of 3. We want to know what is the probability that a randomly selected pretzel takes longer than 19 minutes to bake. So we're looking for the probability that x is greater than 19, which our norm.dist function works finding the area below, or the probability below a value, not above. So here we're going to find 1 minus the probability that x is less than 19. And to do that, I'm going to use my norm.dist function. But I need to set up my variables first, okay? So I'm gonna X out of here. Let's set up, so we have our X value, we have our mu, and let's just call it mean. And then we also have our standard deviation. So our x value is going to be 19, our mean is 15, and our standard deviation is 3. So now we can go ahead, again, we're doing 1 minus the norm.dist, and we are going to find norm.dist of this cell, comma, this cell, comma, this cell, comma, true. And that gives us a value of 0.0192. So this is the probability that if I have a randomly selected pretzel, it's going to take more than 19 minutes to bake. So now, let's also find the probability that a pretzel takes between 12 and 19 minutes. So when we have an interval, we're going to have our larger x come first, and then our smaller x. The mean and standard deviation are the same, but these values are going to be 19, we have 12, we have our mean is 15, and 15, and 3, and 3. And so to find the probability that the time it takes is going to be between 12 and 19 for this pretzel to bake is equal to norm.dist of the larger value, true, minus norm.dist of the smaller value, or the smaller area, I should say, under the curve, smaller probability. And so that comes out to be about a 75% chance that we're going to be between 12 and 19 minutes while baking this pretzel. So that's review of the normal distribution stuff that we did last time. Now we're going to get into the inverse normal stuff. So now we want to find the time required to bake that 97.5% of all the pretzels with the same mean and standard deviation are going to take less than what time to bake. So there's a norm.inverse function that when you put in the probability below that value all the way to negative infinity, this is the probability that in this example, that a value below a 5 takes place. So in the example we were just talking about, we want the probability, we talked about 19 and a couple others, but the probability below this value. And so what this function does is we put in that probability, we put in the mean and the standard deviation, and it will actually spit out the value along the normal curve. So we're looking for the time t such that 97.5% of pretzels take less than this time to bake. So we can use the norm inverse function, which we will do in a second. But I also want to show you what this looks like, okay? So we're looking for 97.5. So if we were to draw this normal distribution, along the bottom here is, in the center is the mean, 15, and then 18, 21, because I'm counting one standard deviation, so I'm adding 3 each time. I don't know if I want my pretzel to take 24 minutes. I'm hungry. I'd rather my pretzel take 6 minutes. All right. So we know that the mean is in the center of this normal curve. And there's 50% of the data is over on this side. So this proportion is 0.50. That takes up this whole side right here. Now, we also know from the empirical rule that one standard deviation away is 68%, which means that this half right here, or this half of that one standard deviation would be half of 68, which is 34%, or 0.34. So up until 18, we have 84%. We also know that it's 95% of the data is within 2 standard deviations, which makes this area right here 0.135, which means when we get up to this point, we're adding 0.135 to 84%, or 0.84, which gives us 0.975, which is exactly the 97.5% that we were talking about. So we know the answer is going to come out to be about 21, just because the area under this curve using the empirical rule is exactly 97.5% at 21. Now the empirical rule is an estimate, so it's not going to come out to exactly that amount, but we can calculate what that amount would be. Again, I'm going to use the norm.inverse function, which takes 3 inputs. The 3 inputs are the probability. So we have probability. It takes in the mean, and it takes in the standard deviation. The probability in this case is we want 97.5%, so 0.975. We're always going to put it in as the proportion, not the percent, because the area under the curve is 1 in total. If you put a number larger than 1 into the norm.inverse function, you will get an error. The mean is 15, the standard deviation is 3. So to find the value along the normal curve, the bottom of the curve, let's see that picture one more time. So the value along here, so we're looking for a value along here. In this case, the 21 is what we were looking for. That's what this is going to spit out. It's going to spit out that 21. And so by using the norm.inverse function and selecting these cells, the proportion or the probability, the mean, and the standard deviation, I'm going to get 20.87, which rounds to 21. So the empirical rule was the estimate. This is the exact area under a normal distribution using the probability density function, which is a very complicated function that we don't need to know because Excel is doing this work for us. So I would say 20.9 minutes is the answer, and we're saying 97.5% of all pretzels will bake within 20.9 minutes. That's the answer to this question. All right. So now we want to do the same thing, but we want to find the time such that 90% of the pretzels take less than time t to bake. Okay? Actually, I'm going to change this real quick. What if we did take, not the time part. What if I said more than time t to bake? Okay? So we're going to find the time t such that 90% of the pretzels take more than this time to bake. Okay. Well, that changes things quite a bit because now the value along the curve, let me clear this out, most of this. I want to keep the numbers along the bottom. Okay. If I said the original problem was find the time t such that 90% of the pretzels take less than this time to bake. Okay, so that would be somewhere around here, and I would fill in this area, and this area is the 0.9, and the norm inverse function is going to spit out this value right here, somewhere between 18 and 21. But that's not what this one's asking now. It's saying more than. So now, basically this is another way to ask this is saying find the time t such that 10% of the pretzels bake in less time than this. So if it takes 90% of the pretzels take more than this time, that means 10% will take less than this time. And so that's going to be somewhere here between 9 and 12. And the proportion I want is always below the value. So this proportion, if what's happening up here is the 90% that we were talking about, then what's here is 0.1. That we have, and now we have to do the calculation and to see what this value is going to be along the bottom. I think it should be between 9 and 12. So I'm actually going to take these, I'm going to copy and paste just to make this easier. I want my probability to be 0.1. And then I'm going to go ahead and use the norm.inverse function. And I'm going to do 0.1, comma, 15, comma, 3. And this came out to 11.15. Oops. So that's this value is here. And so 90% of pretzels will take more than 11.2 minutes to bake. The reason we used the 0.1 is because our norm.inverse function is always going to be less than the time. We need the proportion less than a certain time. All right, I'll see you in the next video where we'll do another example.